Welcome to Rao Chemistry Academy. It is the academy in which all concepts are explained, plus 1 and plus 2 and JE mains. I want to focus on PYQs which came in NEET and JE mains. Today our topic is mole concept, which is most important in entire chemistry. In this some terms are there. First I want to explain about the terms. The first one is atomic mass. Atomic mass, which is indicated with AM. Second one is gram atomic mass, which is indicated with GAM. These two terms I want to explain by taking one example. Helium. Helium, its atomic number is 2, mass number is 4. Atomic number 2 means which contains 2 protons and 2 electrons. What is meant by atomic number? Number of protons present in a nucleus of an atom is called atomic number, or number of electrons present in a neutral atom is called atomic number. Here atomic number is equal, atomic number is 2, atomic number 2 means which contains 2 protons and 2 electrons. How to calculate number of neutrons? This is the formula to calculate number of neutrons. N is equals to A minus Z. A means atomic mass. This is atom. Its atomic mass is 4, that is indicated with A. Atomic number, here atomic number of helium is 2. Atomic number is indicated with Z. Now A means 4, Z means 2, that is equals to 2. Here number of neutrons are 2. Number of neutrons are 2. To calculate number of neutrons in any atom, we are using this formula. That is N is equals to A minus Z. A means atomic mass, Z means atomic number. Here number of neutrons, 2 neutrons. Neutron charge is 0, electron charge is uni negative, proton charge is uni positive. One proton charge is uni positive, one electron charge is uni negative. To calculate atomic mass, we are taking protons and neutrons. Protons and neutrons are account for the mass of the atom. Each proton mass is 1 unit, each neutron mass also 1 unit. Now I want to calculate atomic mass. Atomic mass is indicated with A, that is equals to number of protons plus number of neutrons. Each proton mass is 1 unit. Here 2 protons are there. Protons mass 2, number of neutrons. Here each neutron mass also 1 unit. Here 2 neutrons are there in helium. Total mass of neutrons 2. Now the sum is equals to 4. Beside of that 4 you need to write AMU, atomic mass unit. It is not unit. AMU is not unit like kilograms or grams. What is this? Beside of that 4, why I am writing AMU? Here I am saying this 4 is obtained by adding mass units which are present in atom. Mass units which are present in atom. That 4 is obtained by adding mass units which are present in atom. It is atomic mass. Atomic mass of helium. Atomic mass of helium. Atomic mass of atomic mass of helium, atomic mass of helium. Clear? Here one more point I need to say. 1 AMU is equals to 1.66 into 10 to the power of minus 24 grams. 1 AMU means it is the relative mass of either proton or neutron. It is exact mass of either proton or neutron. Each proton mass or each neutron mass is equals to 1.66 into 10 to the power of minus 24 grams. It is the mass of proton or neutron in grams. It is the mass of either proton or neutron in grams. It is exact mass. It is the relative mass of either proton or neutron. It is the relative mass. It is exact mass of either proton or neutron. Now I want to explain atomic mass and gram atomic mass. Atomic mass and gram atomic mass. I know that 4 AMU. This 4 AMU is obtained from 1 helium atom. 1 helium atom mass is 4 AMU, or 4 AMU mass of helium contains 1 helium atom. 4 AMU contains 1 helium atom, or 1 helium mass is 4 AMU. Remember, this is most important. In 4 AMU of helium, how many helium atoms are there means 1 helium atom is there. Why? Because from 1 helium we got 4 AMU. From 4 AMU we got 1 helium. Okay, these are interconvertible. 1 helium mass is 4 AMU. 4 AMU of helium contains 1 helium atom. Next, I want to explain atomic mass and gram atomic mass. 4 AMU of helium is equals to 1 helium atom. Here I want to write 3 steps which are most important to understand about mole concept. Next, I want to change 4 AMU into grams. 4 AMU means 1 point. Instead of AMU, I want to change 4 AMU into grams. 4 into 1.66 into 10 to the power of minus 24 grams of helium. In which how many atoms are there means 1 helium atom is there. In this 1 helium atom is there. Why? Because just I changed 4 AMU into grams. In 4 AMU 1 helium atom is there. Here also 1 helium atom is there. Now in third step, this is multiplied with 4 into 1.66 into 10 to the power of minus 24 grams into Avogadro's number 10 to the power of 23 of helium. This is Avogadro's number. This number is multiplied with this. Now my question is, in entire this value, how many helium atoms are there means 6.022 into 10 to the power of 23 helium atoms are there. These many number of helium atoms are there. If you simplify this one, it is equals to 4 grams. 4 grams. See this. When you simplify this number, you will get 4 grams. This is equals to these many number of atoms. This is Avogadro number. Avogadro number. This is equal to this. This is equal to this. That means in 4 grams, how many number of atoms are there? Means these many number of atoms are there. In 4 grams of helium, these many number of helium atoms are there. What is the definition for mole? This is amount of substance in which how many number of atoms are there? Means 6.022 into 10 to the power of 23 helium atoms are there. So that it is equals to 1 mole of helium. Mole definition is amount of substance which contains Avogadro number of particles. Avogadro number of particles. The amount of substance which contains Avogadro number of particles, which may be atoms or molecules or ions or electrons or protons or neutrons. This is amount of substance in which these many number of atoms are there, so that it is equals to 1 mole of helium. 1 mole of this is gas. Helium is a gas. 1 mole of any gas which occupies 22.4 liters at STP, standard temperature and pressure. 1 mole of any gas, whether it is helium or nitrogen or oxygen. Helium is atom, oxygen means O2 is molecule. Whatever the gas in atomic state or in a molecule state, if it is 1 mole, it occupies 22.4 liters at STP. 1 mole of any gas which occupies 22.4 liters at STP. Now see the entire connectivity. Already I explained. Up to here 1 helium into this number, these many number of helium atoms. When you simplify this, you will get 4 grams. That means in 4 grams, these many number of helium atoms are there. So that it is equals to 1 mole of helium according to the definition of mole. The definition of mole is the amount of substance which contains Avogadro number of particles. Particles may be atoms or molecules or ions. Here atoms are there, so that it is equals to 1 mole of helium. 1 mole of any gas, not only helium, occupies 22.4 liters at STP. Now I want to say the definition for atomic mass. This is atomic mass. Atomic mass means it is the mass of 1 helium atom. Atomic mass, this is atomic mass, this is gram atomic mass. Atomic mass means it is the mass of, atomic mass is the mass of 1 atom. 1 atom mass. Atomic mass is mass of 1 atom. It is the mass of 1 atom. 1 atom. It is the mass of 1 atom. Gram atomic mass means it is the mass of Avogadro number of atoms. It is the mass of gram atomic mass is the mass of Avogadro number of atoms. Avogadro number of atoms mass equal to 4 grams. 4 grams is known as gram atomic mass. Gram atomic mass is the mass of Avogadro number of atoms. Avogadro number of atoms. It is the mass of Avogadro number of atoms. Avogadro number of atoms. Atomic mass and gram atomic mass. Atomic mass is the mass of 1 atom. Gram atomic mass is the mass of Avogadro number of atoms. Next, mole means amount of substance. Mole means amount of substance which contains Avogadro number of particles. Avogadro number of particles. Here in 4 grams, how many number of particles are there? Already I told particles may be atoms or molecules or ions. Okay. This is gram atomic mass. In this, these many number of atoms are there, so that it is equals to mole. Mole definition is amount of substance. This is amount of substance in which these many number of atoms are there. Avogadro number of atoms are there, so that it is equals to 1 mole of helium. 1 mole of any atom or any gas, 1 mole of any gas occupies 22.4 liters. This is gram molar volume. Gram molar volume. Gram molar volume means it is the volume which is occupied by Avogadro number of molecules or Avogadro number of particles. It is the volume which is occupied by 1 mole of any gas. 1 mole of any gas. Gram molar volume. It is the volume which is occupied by 1 mole of any gas. 1 mole of any gas. These are the definitions. Today I explained gram molar volume, mole, and atomic mass and gram atomic mass. Now you have to take any atom. This is helium, its atomic number is 2, mass number is 4. The mass number is in AMU. Mass number is in AMU, 4 AMU of helium. It is equals to 1 helium atom. In 4 AMU of helium, how many atoms are there? Means 1 helium atom is there. 4 grams of helium, mass number is in grams, it contains 6.022 into 10 to the power of 23 helium atoms. Helium atoms. It is equals to 1 mole of helium. 1 mole of helium is a gas. 1 mole of helium contains 1 mole of helium occupies 22.4 liters at STP. At STP. This concept is applicable for each and every element, not only for helium. If you take sodium atomic number is 11, mass number is 23. If the mass is in AMU, 23 AMU of sodium, it contains 23 AMU of sodium contains 1 sodium atom. 1 sodium atom. 23 grams of sodium contains Avogadro number of 10 to the power of 23 sodium atoms, so that it is equals to 1 mole of sodium. Sodium is a solid. For this there is no gram molar volume. Why? Because it is solid. For gas only gram molar volume is there. Already explained about gram molar volume. For this gram molar volume is not applicable. Remember, the mass number is in AMU, it contains 1 atom. The mass number is in grams, it contains Avogadro number of atoms, so that it is equals to 1 mole of sodium. This is related to atom. This is also related to atom. So that it contains atoms and atoms. This concept is applicable for each and every atom, not only for helium and sodium. You have to take any atom. It contains mass. The mass is in AMU. In that mass, one atom is there. The mass is in grams. It contains Avogadro number of atoms are present, so that it is equals to 1 mole. 1 mole. Now I want to explain molecular mass and gram molecular mass by taking one example. Molecular mass and gram molecular mass. Molecular mass. Third term in this mole concept. Molecular mass. Molecular mass. Molecular mass and gram molecular mass. These two terms I want to explain by taking one example. Oxygen. Oxygen. Oxygen is a gas. Any gas which will exist in molecule state. Any gas which will exist in molecule state. This is oxygen. This oxygen is obtained by adding 2 oxygen atoms. 2 oxygen atoms. I want to explain molecular mass and gram molecular mass. Molecular mass and gram molecular mass. Molecular mass is indicated with mm. Gram molecular mass is indicated with gram, gmm. Gram molecular mass. Here our example is O2. How to get O2? By adding 2 oxygen atoms. By adding 2 oxygen atoms. To explain molecular mass and gram molecular mass, I want to take like this. O plus O gives rise to O2. O plus O gives rise to O2. Here, what is the meaning of this word? This is 1 mole of oxygen atom. In the equation, here coefficients are there. It is nothing. Here nothing is there means 1 mole of oxygen atom. First you have to take like this. You have to take like this. Here, this is 1 oxygen. Just imagine 1 oxygen. 1 oxygen mass is 16 AMU. This is also 1 oxygen. Its mass is 16 AMU. Why? Because oxygen atomic number is 8, mass number is 16. Mass number is 16. If 1 oxygen is there means its mass is 16 AMU. Here also 1 oxygen is there means 16 AMU. Now 1 O2 is there. 1 O2 is there. 1 O2 is there. 1 O2 is there means its mass is 32 AMU. 1 O2 is there means its mass is 32 AMU. 1 oxygen mass 16 AMU. 1 oxygen mass 16 AMU. But here I want to take 16 grams. The mass of oxygen in grams. 16 grams contains Avogadro number of oxygen atoms. Here also Avogadro number of oxygen atoms. Here 32 grams. 32 grams. Try to understand. 32 grams means it contains 1 mole of O2. 1 mole of O2. 16 grams means Avogadro number of oxygens. 16 grams means Avogadro number of oxygens. 32 grams means it contains Avogadro number of oxygen O2 molecules. 32 grams means it contains Avogadro number of O2 molecules. Avogadro number of O2 molecules. Avogadro number of O2 molecules. Just observe clearly. This is oxygen. This is oxygen. This is oxygen. Its mass is oxygen molecule. Its mass is 32. 16 plus 16, 32. It is related to molecule. Its mass is 32. 32 AMU of O2 contains one O2 molecule. One O2 molecule. 32 grams of O2 contains 6.022 into 10 to the power of 23 O2 molecules, so that it is equals to 1 mole of O2. It is a gas which occupies 22.4 liters at STP. For atom I am explaining like that. Here I am taking molecule. O2 is a molecule, its mass is 32. 32 AMU means it contains molecule. In previous examples, when I explained about an atom, they contains one atom, Avogadro number of atoms. Here the mass is 32. If the mass is in AMU, it contains one O2 molecule. The mass is in grams, 32 grams of O2. It contains Avogadro number of molecules. It is equals to Avogadro number of molecules. 32 grams contains Avogadro number of molecules. So that now number of moles, 1 mole of O2. 1 mole of any gas occupies 22.4 liters at STP. This is molecular mass. Molecular mass, the definition for molecular mass is, it is the mass of one molecule. It is the mass of one molecule. This is a gram molecular mass. It is the mass of Avogadro number of molecules. Avogadro number of molecules. Avogadro number of molecules. Molar mass, gram molar mass. The mass in AMU, it contains one molecule. The mass in grams, it contains Avogadro number of molecules, so that it is equals to 1 mole of O2. It is a gas. Gas occupies 22.4 liters. 1 mole of any gas occupies 22.4 liters at STP. This is called gram molar volume. It is the volume which is occupied by 1 mole of any gas. It is in atomic state or in molecule state. This is a gram molar volume. This explanation apply for any molecule, whether it is N2 or Cl2 or F2 or CH4 or NH3, ammonia, methane. This concept applicable for each and every molecule. Same explanation is there. Mass is in AMU, it contains one molecule. Mass is in grams, it contains Avogadro number of molecules, so that it is equals to mole. If it is a gas, it occupies 22.4 liters at STP. Just observe this one. Then you will get complete clarity about this. 1 oxygen means 16 AMU. Here also 1 oxygen means 16 AMU. When you add O2, then you will get 2 oxygens, then you will get O2. Here O2, if it is 1 molecule of O2, its mass equal to 32 AMU. 32 AMU. Here I want to I want to take another way. Here this is oxygen. If it is here Avogadro number of oxygen atoms are present means its mass equal to 16 grams. Here also Avogadro number of oxygen atoms are there means it is equal to 16 grams. Avogadro number of O2 molecules are present means 32 grams. Now oxygen O2 its mass equal to 32. In atom what I explained in the same way 32 AMU the mass in AMU it contains one O2 molecule. The mass in grams it contains Avogadro number of molecules. It is equals to 1 mole of O2. If it is gas it occupies 22.4 liters at STP, that is called gram molar volume. This is a simple explanation for mole concept. With these terms we will do number of problems. It is an easy way to understand the concept. Here I explained only 5 terms. First one is atomic mass, second one is gram atomic mass, third one is molecular mass, fourth one is gram molecular mass. Molecular mass means it is the mass of one molecule. 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 Gram molecular mass means it is the mass of Avogadro's number of molecules. Gram molar volume means it is the volume which is occupied by 1 mole of any gas, whether it is in atomic state or in molecule state. Okay, I want to discuss some problems related to this. One more example I want to explain related to molecular mass and gram molecular mass. N2 its mass 28. How to get N2? By adding two nitrogen atoms. Each nitrogen mass 14 and 14. 14 plus 14, 28. If that mass is in AMU, 28 AMU of nitrogen is equals to 1 N2 molecules. 1 N2 molecule. If the mass is in grams, it contains Avogadro number of molecules. It is equals to 1 mole of N2. It is a gas which occupies 22.4 liters at STP. Okay. This is the amount of substance which contains Avogadro number of particles are there, so that it is equals to 1 mole of N2. Here I am explaining about atom and molecule. Atom contains atomic mass and gram atomic mass. Molecule contains molecular mass and gram molecular mass. You have to take number of examples. For example, CH4, its mass equal to 16. How to get this CH4? 1 carbon, 4 hydrogens. Now the mass in AMU of CH4 is equals to 1 CH4 molecule. 16 grams of CH4 is equals to Avogadro number of molecules. Avogadro number of molecules. Avogadro number of molecules. It is equals to 1 mole of CH4. It is equals to 22.4 liters at STP. It is a gas. CH4 is a gas, so that it occupies 22.4 liters at STP. That is a gram molar volume. It is molecular mass. It is gram molecular mass. It is molecular mass. It is gram molecular mass. I think you have complete idea about atomic mass, gram atomic mass, molecular mass and gram molecular mass. I want to solve simple problems to understand about these concepts. What are these concepts means? Atomic mass, atomic mass, molecular mass, gram molecular mass and gram molar volume. The first problem is find number of moles in 2.3 grams of sodium. In the solution, you have to write. To solve this, here you need to find number of moles in 2.3 grams of sodium. This is easy problem. For understanding purpose, I want to explain. For each and every problem, better to remember the mass numbers. Sometimes in exam, in NEET or JEE mains, that values are given. Its atomic number is 11, mass number is 23. From the basic concepts, I know that 23 AMU of sodium is equals to 1 sodium atom. 23 grams of sodium is equals to 6.022 into 10 to the power of 23 sodium atoms. It is equals to 1 mole of sodium. For each to solve any problem in mole concept, you need to know this basic information. Here I know that 23 grams of sodium is equals to 1 mole of sodium. 23 grams of sodium is equals to 1 mole of sodium. Now, here in the problem, what is there? Find number of moles in 2.3 grams of sodium. I know from the basic data 23 grams of sodium equals to 1 mole of sodium. Now 2.3 grams of sodium is equals to how many moles? How many moles? I want to calculate this x. How many moles? This x we need to find. To solve this problem, do cross multiplication. Cross multiple. X into 23, x into 23, 23x, 23x. Multiple these two. X into 23, 23x is equals to 1.1 into 2.3. Then x is equals to 2.3 by 23 to To solve this, you need to multiple with 10 and divide with 10. 2.3 into 10 means 23 by 23 into 1 by 10. 1 by 10 means 0.1 mole. This is easy problem only. For understanding purpose, I want to give primary information. In simple way, I want to solve each and every problem. Find number of moles in 40 grams of helium. Find number of moles in 40 grams of helium. Again, you need to write the basic information. This is helium, atomic number 2, mass number 4. 4 AMU of helium is equals to 1 helium atom. 4 grams of helium is equals to 6.022 into 10 to the power of 23 helium atoms. It is equals to 1 mole of helium. Well known basic data it is. From the basic data I know that 4 grams of helium is equals to 1 mole of helium. But our problem data is different. 40 grams of helium is equals to how many moles? This x we need to calculate. Cross multiple. X into 4, 4x is equals to 1 into 40. Then x is equals to 40 by 4, 4 ones, 4 tens. 10 moles. 10 moles. Find number of moles in 1.6 grams of methane. Methane CH4. Methane means CH4. In the solution, we need to write basic data. CH4, its mass equal to 16. Carbon mass is 12. Each hydrogen mass is 1. 4 hydrogens are there. Carbon mass is 12. Hydrogen mass is 1. 4 hydrogens are there. 12 plus 4 is equals to 16. You need to write the basic data. 16 AMU of CH4 is equals to 1 CH4 molecule. 16 grams of CH4 is equals to 6.022 into 10 to the power of 23 CH4 molecules. It is equals to 1 mole of CH4 methane. From the basic data I know that 16 grams of CH4 is equals to 1 mole of CH4. 1 mole of CH4. From the problem, what data we have? Find number of moles in 1.6 grams of methane. Here the mass is 1.6 grams of methane equals to how many moles? 16 grams equals to 1 mole of CH4 Now 1.6 grams of CH4 equals to how many moles? Just do cross multiplication. Cross multiple. X into 16, 16x is equals to 1 into 1.6. Then x is equals to 1.6 by 16. Just 1.6 by 16. You need to 1.6 by 16. We need to multiple and multiple with 10, divide with 10, that is equals to 16 by 16 to 1 by 10. 1.6 into 10, 16. Here the answer is 0.1 mole. 0.1 mole. This is neat problem. Here problems are very easy if you know the basic concepts. First read the problem, try to understand what they are asking, what they are given. The right option for the mass of CO2 produced by heating 20 grams of 20% pure limestone is, what is the right option? They are asking about CO2. They are given the information regarding limestone. After reading this problem, we need to get idea about the equation. Sometimes in the problem, the equation is given. Whether the equation is given or not, no problem. We need to have idea about equation. How to get CO2 from limestone? What is the proper equation for this problem? When we heat limestone, limestone means calcium carbonate, then we will get calcium oxide and carbon dioxide. First we need to write a balanced chemical equation. Balanced chemical equation. After reading this problem, we need to write the complete equation with balance. Now we got CO2 when we heat limestone or calcium carbonate. The problem is there in between carbon dioxide and limestone. This is limestone formula. From this equation, we know that the meaning of this equation is 1 mole of calcium carbonate when we heat, it will be converted into 1 mole of calcium oxide and 1 mole of carbon dioxide. This is basic information. Before solving any problem, compulsory we need to balance the chemical equation according to law of conservation of mass. The problem is there in between carbon dioxide and limestone. So that we need to take only the two. What is the meaning of this equation? Here nothing is there means 1 mole of calcium carbonate. When we heat, it can produce 1 mole of calcium oxide and 1 mole of CO2. Why we are taking these two means in the problem they are asking about limestone and carbon dioxide. There is a link between calcium carbonate and carbon dioxide. First I want to write the information from the basic chemical equation. I know from this equation I know that 1 mole of calcium carbonate when we heat, it can produce 1 mole of CO2. From the equation I know that when we heat 1 mole of CaCO3, it can produce 1 mole of CO2. In the problem they are asking about mass of CO2. Why? Because options are in grams. That means they are asking about CO2. What they are asking means mass they are asking. Sometimes they will ask volume also. Sometimes they will ask moles also. Here they are asking a mass of CO2. How much CO2 is produced? When we heat 20 grams of 20% of pure limestone. From the equation I know that 1 mole of CaCO3 produce 1 mole of CO2. These moles I want to convert it into mass. I know that CaCO3 mass 100. How I am getting that value? Calcium 40, carbon 12, oxygen 16 into 3, 48, total 100. Total 100. Okay, 48. Total 100. 1 mole of CaCO3 equals to 100 grams of CaCO3. It is equals to 1 mole of CO2 means 44 grams of CO2. This is the data from the equation only. Till now I did not touch the problem data, the data of the problem. Now from the equation, from the basic equation, I know that 100 grams of calcium carbonate, when we heat, it can produce 44 grams of CO2. 44 grams of CO2. Now our problem data. The right option for the mass of CO2 produced by heating, the mass of CO2 produced, I need to calculate the mass of CO2. When 20 grams of 20% of pure limestone is heated, 20 grams, in 20 grams, 20% means 20 by 100. This is important in this problem. Problem is easy, but this is important. How much amount of limestone they are taking means 20 grams and 20%. In 20 grams, 20% of limestone is participating. 20 into 20 by 20% means 20 by 100. 0, 0, 2 zeros cancel. Okay. Now multiple, cross multiple. X into 100. 100x is equals to here 2 into 2, 4. 4 into 44 is equals to 176. 4 into 44, 176. This 100. X is equals to 176 by 100, that equals to 176 0.01. This is equals to 1.76 grams. 1.76 grams. This is our option. It is second problem. After reading this problem, we need to get idea about this. This equation we will see in chemical equilibrium and 7th A group elements. 7th A group elements. Haber's process. It is important question in +1. The number of moles of hydrogen molecules required to produce 20 moles of ammonia through Haber's process. In the solution, after reading this problem, you will get idea about this equation. We will get ammonia when we heat, when hydrogen reacting with nitrogen. When hydrogen reacting with nitrogen, this is Haber's process. It is a reversible process. Reversible reaction. Equilibrium exists in between reactants and products. Compulsory for each and every equation, what we need to do, we need to balance the chemical equation. Here 2 nitrogens are there. Sorry, here 1 nitrogen is there. Here 2 nitrogens are there. So that we need to take 2. 2 into 3 hydrogens. Here only 2 hydrogens are there. Take 3. 3 into 2. 6 hydrogens. This is balanced equation. Write chemical equation and balance. Compulsory we need to balance the chemical equation. That is most important. After reading this problem, we will get idea about what they are asking, what they are given. The number of moles of hydrogen molecules required. They are asking the question on hydrogen. To produce 20 moles of ammonia, there is a relation between hydrogen and ammonia. So that we need to take the two only. The two only. Here, from the balanced chemical equation, we know that when 3 moles of hydrogen reacting with 1 mole of nitrogen, it can produce 2 moles of ammonia. From the balanced equation, I know that 3 moles of hydrogen produce 2 moles of ammonia. They are asking about moles only, so that I am leaving the moles like this. I no need to convert into mass. Why? Because the problem is related to moles. When 3 moles of hydrogen reacting with 1 mole of nitrogen, 3 moles can produce 2 moles of ammonia. Now our question is, to get 20 moles of ammonia, how many moles of hydrogen is required? That is our question. This x we need to calculate. Do cross multiple. Do cross multiple. X into 2, 2x, x into 2, 2x is equals to 20 into 3, cross multiple, 20 into 3, 20 into 3. Then x is equals to 60 by 2. This is equals to 2 ones, 2 30s. It is our option. Okay.